Venus is often called Earth's evil twin. The thing is, this world once started off quite similar to our home planet. But later, something went wrong. These days, the two planets are relatively close and similar in size. But Venus's atmosphere is very different from that on our planet, all thanks to a runaway greenhouse effect that has been going on for a long time. The surface of Venus can get even hotter than the surface of Mercury, 864 degrees F. And the surface pressure feels as if you're more than half a mile underwater. The thick atmosphere presents its own challenges. Its clouds consist of sulfuric acid, which is used in lead-acid batteries, as well as industrial cleaners. And if you decided to land on the planet, you'd have to survive atmospheric entry, with friction heating you up to 20,000 degrees F. Still, people have always wanted to explore this inhospitable world, and we can't but talk about the Venera program. During the 1970s and 1980s, several spacecraft studied Venus from orbit and from its hostile surface for an hour or so at a time. The 10 successful Venera landers provided us with most of the data we have today about the surface of this mysterious planet, including surface composition, direct measurements of atmospheric conditions, and sets of unique images. At the same time, astronomers got their hands on these treasures only after a series of annoying failures. They started with Venera 1, launched in February 1961. Each consequent spacecraft was somehow improved and upgraded. But it still wasn't until the fifth group of Venus-bound space probes launched in 1967 that one of them, Venera 4, reached its target and sent data from Venus. Before that, Venera 2 and 3, launched in November 1965, were supposed to land on Venus, but both of them failed in transit. 11-foot-tall Venera 4 was a hefty thing. Its bottom lander was a bunch of instruments and a battery wrapped up in a pressure shell equipped with a parachute. This probe reached Venus in October 1967 and successfully launched the lander. The mother spaceship sent the probe flying over the planet, and it entered Venus's atmosphere. Temperatures were reaching 20,000 degrees F, and the entry force was as great as 450 G. It didn't prevent the onboard instruments from analyzing the atmosphere and sending back data. The first recorded temperature was 102 degrees F, and atmospheric pressure was similar to that on Earth. But the deeper the probe went, the higher the numbers became. 10 atmospheres, 20. They kept going up much higher than engineers had anticipated. 93 minutes into the mission, when the probe was still more than 16 miles above the surface of the planet, Venera 4 cracked open near its top and crashed. At the crash point, the measurements showed 22 atmospheres and 530 degrees F. Scientists realized that they needed a bigger spaceship. After some intense engineering, Venera 5 and Venera 6 saw the light of the day. Engineers did everything they could to make the landing probe stronger, but they were pressed for time. That's why Venera 5 and 6 were not fully prepared when they went on a mission. That's why Venera 5 transmitted data for a mere 53 minutes before succumbing to temperatures of 600 degrees F and pressures of 27 atmospheres. And Venera 6 lasted for 51 minutes. In any case now, the leaders of the project knew what it would take. 840 degrees F, 100 atmospheres, corrosive acids. They seemed to be prepared. They found new materials to build the probe. They got a hotter and stronger test chamber for the trials. They modified the parachute to make the lander fall faster so that the probe could spend as much time on the surface as possible. The lander was also designed in the shape of an egg and made of titanium, so its surface was smooth and had just a few ports, welds, and substructures. The insides were lined with a shock absorber and insulation layer. The chamber was also to pre-chill to freezing temperatures before entry. And Venera 7 was finally a success. It reached the planet in December 1970, separated from the mothership, and went down into the atmosphere. The probe transmitted data for 35 minutes, and things seemed smooth. But then, its chute melted, and the probe dropped like a rock, hitting the ground at 35 miles per hour and bouncing. Then, a second after the landing, the signal was abruptly cut, It looked like the probe crashed to bits. Shockingly, a few months later, while looking through all the data they managed to get, engineers rediscovered the signal. It was super weak and lost amidst the noise. Apparently, when Venera 7 bounced, it misaligned the antenna. The probe rested on its side, which weakened the signal to 1 or 3% of its initial strength. The probe kept transmitting data for 23 minutes. After that, the temperatures got too high and melted its shell. Venera 8, launched in 1972, had a similar design and experienced a similar fate. Venera 9 and 10 were a new generation of probes. They could send back black and white photos. It was actually the probe's main goal, to send the first ever photographic panorama from another planet. Venera 9 and 10 were 5 times heavier than their predecessors and weighed 5 tons at launch. The lander was 6.5 feet tall. It was basically a hermetically sealed titanium sphere that was supposed to hold the instruments. It was bolted with gold wire seals. Inside, there were shelves of beryllium and electric fans, whose main goal was to disperse heat to prevent instrument failure. On the bottom of the lander, there was a shock-absorbing ring. And at the top, there was a titanium ring that looked like a hat. It served as an aero brake. The parachute was supposed to detach at 30 miles above the surface, and the aero brake had to do the rest. In October 1975, Venera 9 and 10 arrived at Venus and landed as planned. Venera 9 was the first to land. It touched down on a slight slope, a volcanic crater or a hill, and kicked quite a bit of dust while landing. One of its 2 cameras succeeded in photographing and transmitting data, and soon scientists saw the first ever pictures of the surface of Venus. It was mostly sharp rocks, soil, and a distant horizon. The sun was slightly obscured by clouds that day. A gentle breeze was blowing. Overall, it was a pleasant morning. If you didn't pay attention to crushing pressure, almost completely waterless atmosphere, insanely high temperatures, and corrosive acids. Venera 10 landed in the same way a few days later, but the terrain it landed on was much more boring. Just a rolling plain with hardened pieces of magma. Both probes transmitted for 40 to 60 minutes until their orbiters went out of range. When it happened, the temperatures inside the probes were reaching 140 degrees F. The orbiters later burned up in the atmosphere after completing their mission. Venera 11 and 12 could have been a success, but a mysterious electric anomaly messed up with their cameras, so their trip was quickly forgotten. And Venera 13 and 14 entered the picture. They had improved scientific instruments and cameras that could take color images, and new heat-resistant technologies were used during the creation of these probes. Venera 13 arrived first and landed as planned. It took 2 photos, one black and white and the other in color. In the photos, one could see a surface of pebbled, loose soil and outcroppings of bedrock. It all looked pretty similar to the surface of the ocean. In the distance, there were rolling plateaus and an orange sky. The images taken later by Venera 14 showed a more weathered plain with less loose soil and fine-grained rocks. The 2 probes also sent back what they heard. It mostly sounded like a gently blowing wind with hints of distant rumbling. Could be Venus quakes. Venera 13 and 14 were the last landers to touch the surface of the planet. Venera 15 and 16 just flew around Venus, mapping its topography from orbit.
Oh man, the sun did it again! It just blasted a huge cloud of plasma into space. This time, it was one of the fastest and most powerful eruptions of this solar cycle. It was so strong that the shockwave hit Venus, our next-door neighbor. That's when scientists got worried and started asking a scary question. Could Earth be next? Well, let's just cut to the chase. If your GPS and internet have been working fine over the last few weeks, and your city hasn't had any big blackouts lately, you already know the answer. No, that powerful blast didn't hit Earth. Or at least we didn't feel any real effects from it, because this event happened on October 21, 2025. And if our planet had been in its path, we would have felt the effects only a few days after that date. You see, we're talking about coronal mass ejections, or CMEs. From time to time, the Sun throws a giant cloud of superhot plasma into space, straight from its outer layer, the corona. Think of plasma as a superheated gas. It's what the Sun is made of, and it's full of tiny charged particles, positive ions and negative electrons. These outbursts happen because the Sun's magnetic field is always moving and twisting. Sometimes the magnetic lines get tangled up, then suddenly snap and reset. This process is known as a magnetic reconnection. And when that happens, boom, the Sun launches a CME. A single coronal mass ejection can throw billions of tons of material into the solar system in one shot. And it can create a shock wave. That shock wave can speed up charged particles, which raises the chance of a radiation storm. And if a planet is in the way, yeah, that can be trouble. The tricky part is that CMEs are pretty unpredictable. They can blast out in different directions, and they don't all move at the same speed. The fastest ones race through space at millions of miles per hour. If one is aimed at Earth, it can get here in as little as 15 hours. Slowest ones can take days to get here, but even then, it's usually somewhere between 1 and 5 days. It's not like months. Since this big blast happened a while ago, it's safe to say that, well, we're safe. And honestly, even if it had hit Earth, we'd probably be safe anyway. Sure, a strong CME can mess with satellites, disrupt radio and internet signals, and even knock out power grids for a while. But it's not the kind of thing that ends the world or wipes out humanity. So, take a breath. Even a really powerful solar eruption isn't going to destroy Earth. Unfortunately, we can't say the same thing about Venus. CMEs hitting our neighboring planet are actually one of the reasons Venus can't support life, at least not what we consider life. But don't worry, we'll get to that part later. First, let's dive into this recent solar outburst and what made it so extreme. This one came from the far side of the Sun, the side we can't see from Earth, and it came from an especially active sunspot area called 4246. This is a new, huge, messy sunspot that's been responsible for the latest round of solar storms headed our way. The big blast happened right after that region rotated past the Sun's western edge, so it was out of view from Earth and from most weather satellites. Thankfully, the event was caught by an instrument on a NOAA satellite called CCOR-1. Think of it like a special camera designed to spot big solar blasts even when they happen on the far side of the Sun. That's why it's strategically placed so high above Earth, and it orbits about 22,000 miles over the equator. The CCOR-1 manages to capture those images by blocking the Sun's blinding surface, so it can see the faint glow around it and track huge plasma clouds as they spread out into space. Now, let's talk about speed. NASA estimates that the CME in October was moving at about 820 miles per second. But the first radio signal suggested it might have been even faster, close to 1,537 miles per second. Trust me, that's crazy fast for a coronal mass ejection. To put that in perspective, only a handful of blasts in modern history have been quicker. One famous example happened in 2017 during an X-class flare rated around X8. So according to NASA, X-class means the strongest kind of solar flare. The number tells you how strong it is. An X1 is the baseline, an X2 is twice as strong, an X3 is 3 times as strong, and so on. So yeah, an X8 flare is something huge. Back on Earth, that 2017 event did mess a bit with high-frequency radio signals for a while. But for us, that was pretty much it. Mars was a different story. When the same event hit the red planet, it heated the upper atmosphere in an uneven way. In the hottest areas, scientists saw the top 2 layers, the thermosphere and the ionosphere, start interacting more than usual because of the blast. And that had a real effect. Oxygen began escaping into space much faster than normal. In other words, that brief event made Mars lose part of its atmosphere at a higher rate. Now, when we talk about this recent burst, the story is kind of similar, but with a twist. This time, Mars wasn't the main target, Venus was. The planet was sitting right in the path of the solar burst, so when the blast hit, Venus got slammed with a storm of charged particles. Now you might be wondering, why is it a bigger problem when a solar eruption hits planets like Venus or Mars, but not as big of a deal for us here on Earth? Well, it's because of Earth's magnetic field. So big blasts from the sun can mess with the atmosphere around a planet. But on Earth, a lot of that impact gets blocked by a natural magnetic bubble called the magnetosphere. Good thing, huh? Here's how it works. A wave of plasma comes from the sun and slams into the magnetosphere, the region around Earth controlled by our magnetic field. That magnetic field pushes most of the charged particles away, kind of like a shield, but not all of them. Some particles still sneak through and crash into the upper atmosphere. When that happens, we can get geomagnetic storms. These storms create amazing auroras. They can also mess with satellites and communication networks, like we talked about earlier. But some planets, like Venus, don't have a strong magnetic field like Earth does, and that can be bad news. Because when a CME wave reaches Venus, the charged particles crash straight into the atmosphere and, over time, slowly peel parts of it away. Now here's a real example. On December 19, 2006, the Sun released a small, slow CME. Even though it wasn't moving fast, it was still strong enough to do damage. About 4 days later, it reached Venus and ripped away a large amount of oxygen from the planet's atmosphere, sending it off into space for good. Or bad. And this is actually one of the big reasons why planets like Venus are uninhabitable. Without a strong magnetic field, CMEs can slowly strip away their atmosphere, blast the surface with dangerous radiation, and create brutal space weather conditions. Venus is a perfect example. It is the hottest planet in our solar system, being 100 times hotter than Earth. Its atmosphere is insanely thick, and the pressure over there is insane, so much so that the longest any spacecraft has survived on its surface before being crushed is a little over 2 hours. Scientists think that getting hit by solar eruptions without a proper magnetosphere to protect it helped push Venus toward this extreme world. And by studying what happens to planets like Venus, we can learn something bigger: how important a magnetic shield might be for life on other worlds we find outside our solar system. So Venus and Earth are so different that a foolish question like, what's longer, a day or a year, that makes absolutely no sense on Earth, totally makes sense on Venus. A day on Venus is indeed longer than a year. If we put it into Earth's perspective, a day on Venus would equal 243 Earth days, while a year would only last 225 days. So it's like your birthday is every day. Venus is often nicknamed Earth's evil twin. Their differences are so stark, you'd think they're from different galaxies altogether. Just to give you an idea of how far apart they are, if the day-to-year ratio wasn't enough, the Earth rises in the west on Venus but sets in the east. These days, one of the very few similarities between these two is their size. But try to imagine a time when Venus and Earth were like peas in a pod, besties since the beginning of the solar system. Venus used to be the life of the party. NASA scientists think Venus might have even hosted a liquid water ocean and surface temperatures that could have welcomed life for up to 2 billion years. But modern-day Venus is a different story. We're talking extreme temperatures and a thick carbon dioxide atmosphere. So, what led to this cosmic makeover? Size, location, and attitude. I mean that the distance from the Sun and internal heat played a huge role in shaping Venus and Earth's destinies. By the way, there used to be 3 siblings that could have hosted life: Venus, Earth, and Mars. Now imagine 3 cupcakes in an oven. Once they were fully baked, they were taken out of the oven. One of them was put in front of an open window in the middle of winter. Another was carefully placed on a table and covered with a nice clean kitchen towel. And the last one was accidentally forgotten and left in the oven. Oops. Mars, Earth, and Venus are like those cupcakes. Mars got too cold and not welcoming. Earth is still nice and warm and well protected from all the unpleasant things, just like the towel protects that lucky cupcake. And Venus got scorching hot and impossible to consume. In terms of development, Earth took the slow and steady route, maintaining its oceans, stable atmosphere, and biodiversity. Venus, on the other hand, cranked up the temperature, evaporated its oceans, and went all in with greenhouse gases. As a result, we have a planet where you'll melt faster than a snowman in July. Mars, on the contrary, will turn you into an ice popsicle within seconds. But chances are, it might have been pretty hospitable at some point. Some scientists believe that Mars used to be covered with flowing rivers and lakes and had no water shortages. Even today, Mars still has an ocean called Oceanus Borealis, or rather, the remains of what once used to be an ocean. It lost nearly all its water over time. Now, the sources of water on Mars include polar ice caps and minerals and rocks. According to estimates, only 1% of all that water evaporated, while 99% is still locked in the red planet. Ice polar caps are pretty simple to understand, as we have the same thing on Earth. But rocks containing water? Simple. There are at least 4 types of hydrous minerals on Mars. There are hydrous clays made of silicon oxygen, and the cool thing about them is that they can even contain magnesium and iron, which are sulfur-based hydrous sulfates. Now, don't you? I know you thought of the smell of rotten eggs. But it's typical of hydrogen sulfur and not just sulfur. These minerals have water incorporated right into their chemical formulas. There's also hydrous silica, which has water locked in its formula too. Scientists have experimented with growing plants using Martian-like conditions and found success with alfalfa. Harvesting alfalfa also helped improve the growth of other crops like turnips and lettuce. While water may be available on the red planet, the air on Mars is mostly carbon dioxide. On the bright side, and the Mars Oxygen In Situ Resource Utilization Experiment, the Mars Oxy, can produce oxygen on Mars, which could be crucial for future missions. As for energy sources on Mars, solar, wind, and geothermal energy are a few promising options. Solar power is less effective on Mars due to weaker sunlight and dust storms. But wind power and geothermal energy could serve as reliable alternatives. With these sources in place, humans could potentially sustain life on Mars. But let's get back to comparing our sibling planets. While both Mars and Earth have moons, and Mars even has 2 of them, Venus has 0, just like Mercury. Due to its proximity to the Sun and the star's gravitational pull, Mercury lacks the ability to retain its own moon. The likelihood of any moon orbiting Mercury either colliding with the planet or being drawn into the orbit of the Sun is high. That's all clear and understandable. But the absence of moons around Venus remains an unsolved puzzle for scientists. Despite Venus's scorching hot temperatures, scientists think that even today it might not be as hostile to life as we once thought. A recent MIT study found 19 amino acids surviving in a Venus-like solution for the whole month. Yep, some like it hot. Also, Rocket Lab and the Massachusetts Institute of Technology are teaming up to send an uncrewed spacecraft, Venus Life Finder, on a mission to Venus. This spacecraft will search for signs of life in the Venusian atmosphere using a special instrument called an autofluorescing nephelometer. And no, I didn't make that up. Originally set to launch in 2023, the mission is now pushed back to December 2024 with arrival at Venus in May 2025. The goal of the mission is to discover organic compounds in Venus's atmosphere, which could point to the possibility of habitable conditions in the cloud layer. The spacecraft is designed with a Photon Explorer cruise stage and a compact atmospheric probe equipped with that nephelometer thingy. The small probe will descend through the Venusian atmosphere, collecting data on cloud particles and organic compounds. In 2020, scientists made a big announcement about finding phosphine on Venus, a compound that could be linked to life. While they're still working on confirming this, Using information from telescopes or even past missions, there might be evidence hidden in old NASA data received from Venus that could shed more light on the discovery. The potential presence of phosphine on Venus has stirred excitement and caution among scientists. To make sure, they need more data from telescopes or new space missions. If they find this gas, it might mean there is some form of life producing it in the planet's clouds. This discovery would be a huge step toward understanding Venus better. Some experts think that sending probes to Venus to directly detect phosphine would be the most effective way to confirm its presence. An 80s NASA mission may have already detected phosphine, but scientists back then didn't realize it. Now, this data is being re-evaluated to uncover any overlooked evidence of the presence of the gas. This could also suggest that the compound has been in Venus's atmosphere for decades, raising questions about its source. But not everyone is convinced of this interpretation, which evokes a debate among scientists about the true nature of the detected gases. Old data from other missions may also hold clues about phosphate on Venus. While new spacecraft are going to explore the planet, it's possible that the key to unlocking this mystery lies in decades-old mission records. In total, there have been 46 space missions to Venus, including some flybys where gravity lent a helping hand. The last time we successfully landed a spacecraft on Venus was way back in June 1985 as part of the Vega 2 mission. So, let's see what Venus Life Finder will discover.
What if I told you that humans could have evolved on a planet other than Earth? And we're not talking about Mars here. This planet is Venus, one of the most toxic and dangerous places in our solar system. But imagine this. Once upon a time, Venus was a happening place for potential life. And maybe, just maybe, life was there. How is that possible? And what happened? Let's figure it out. Picture this, a planet swathed in clouds and named after a deity of love and beauty, Aphrodite. Sounds enchanting, right? But don't be fooled. Venus, our neighbor, is the second planet from the Sun, and it's no picnic. Its surface is hot enough to melt lead, and the atmosphere is so thick that the Sun is just a blurry smudge. As you get closer to it, things turn from dreamy to downright hellish. About 30 miles up in the atmosphere, temperatures range from 86 to 158 degrees Fahrenheit. And this is just the beginning. To survive on Venus, you'd need super-duper insulation, because temperatures can reach a sizzling 900 degrees Fahrenheit. Plus, the weight of the atmosphere would bear down on you like being submerged deep in the ocean. The atmosphere is mostly made of carbon dioxide, and down at the surface, it behaves in a corrosive way due to the intense heat and pressure. The sky is sulfur yellow, and the clouds are composed of sulfuric acid. The surface is filled with active volcanoes and craters. Yikes! It's like the environment itself turns against you. Venus is often referred to as the Earth's twin. That's because Venus is almost as big as Earth, just a tad smaller, and these two planets look quite similar on the inside. But in reality, Venus is more like Earth's opposite than its twin. It spins in the opposite direction, has longer days than years, and has no seasons to speak of, not even mentioning its crazy weather conditions. But believe it or not, it wasn't always this way. A long time ago, around 3 billion years after it was born, Venus might have been a watery wonderland like our beloved Earth. It had a cozy climate, and researchers think there was even enough time for life to emerge. But how do we know that? Back in 1978, NASA's Pioneer Venus spacecraft discovered hints that Venus might have had oceans on its surface. Since then, scientists have sent more missions to explore the planet, and they've learned some fascinating things about its past. NASA researchers have come up with 5 cool simulations to show what Venus was like with different amounts of water covering its surface. To create these simulations, scientists used a fancy 3D model that takes into account the gases in Venus's atmosphere billions of years ago and how they are now. They also considered how the sun's radiation has changed over time, getting warmer as it ages. And it turns out that Venus used to be a lot like Earth. All simulations suggest that Venus could have had stable temperatures, ranging from a comfy 68 degrees Fahrenheit to a toasty 122 degrees Fahrenheit. In some of the simulations, Venus had a similar landscape to what it has now, with a shallow ocean and some water trapped in the soil. In others, they imagined Venus having a deep ocean or even the entire surface covered in water. Surprisingly, in all these scenarios, Venus could have maintained temperatures suitable for liquid water. Now, imagine a parallel universe where Venus stayed this way. What if things turned out differently and it was still as cozy as Earth? It could have been the perfect place for humans. Its oceans would have provided a nurturing environment for life to flourish and evolve. The temperatures would have been like a perpetual springtime picnic. Can you imagine lounging under a Venusian palm tree, sipping Venusian lemonade? Ah, the good life. Also, Venus had a slow rotation compared to Earth. Days would have stretched out, giving us more time to enjoy life's simple pleasures. Instead of 24 hours, a Venusian day might have lasted for months. You could have taken an extended vacation and still had time for a full makeover. And what about the higher atmospheric pressure? It may sound intimidating, but it could have actually worked in our favor. The higher pressure would have provided a cozy and snug environment, like being wrapped in a warm, fluffy blanket. No need to worry about the chilly winds of other planets. Venus would have had us covered. Oh, and remember the acidic atmosphere? It may sound strange, but it would have had its benefits too. Venus would have been a carbon dioxide-loving paradise. Plant life would have thrived, creating lush landscapes and filling the air with fresh oxygen. So in this scenario, Venus could have been our haven among the stars. So what happened? What has ruined Venus? Unfortunately, everything changed about 700 million years ago. There was a huge event that caused Venus to change completely, turning it into the hostile place it is today. It experienced a runaway greenhouse effect, which made its atmosphere super thick and scorching hot. A runaway greenhouse effect sucked all the water into space, leaving behind a scorching surface of volcanic rock with thick, crushing atmosphere and acid clouds. Yikes. So what caused this catastrophic transformation? Well, our experts believe it may have been due to volcanic activity. When magma and molten rock reached the surface, they released a bunch of carbon dioxide into the atmosphere. If the magma cooled before reaching the surface, it created a barrier that prevented the gas from being reabsorbed. Massive amounts of gas were released into the atmosphere. Something similar happened on Earth with the Siberian traps, which caused a mass extinction. Venus had its own mega transformation. So, unfortunately, this catastrophe changed the history of our solar system once and forever. But here's the fascinating part. This little mysterious planet still could teach us a lot about the origins of life. For example, if Venus was once habitable, it opens up exciting possibilities for exoplanets in the Venus zone of other star systems. Maybe they could support life too. There's also a critical question that scientists ponder. How do these life-friendly worlds come into existence? Early on, Venus and Earth were strikingly similar. They were close in size, had similar structures inside, and even had oceans in their youthful days. But one planet turned into a scorching inferno, while the other became a thriving hub for abundant life. Why is that? And finally, believe it or not, we can't completely rule out the possibility of life on Venus even now. Up high in the thick yellow clouds where the temperature, air pressure, and chemistry are friendlier, there might be a chance. That's a range where earthly life, like tough extremophile microbes, could potentially survive. The atmospheric pressure up there is similar to what we experience on Earth's surface. We've even noticed strange dark patches in its atmosphere that come and go. Dark streaks persist, defying hurricane-force winds and absorbing ultraviolet radiation. Scientists are scratching their heads over these persistent streaks. They suspect they could be made of fine particles or ice crystals. But here's where it gets wild. Astrobiologists consider another option. Could these streaks be made up of Venus-style microbial life? They theorize that ring-shaped sulfur compounds in Venus's atmosphere could act as a protective coating for the microbes. Wouldn't that be amazing? That's why, by studying why Venus went down a different path in terms of habitability, we can unlock the secrets of what makes other worlds just right for life. However, there are still mysteries to solve. We need more missions to study Venus and understand its history better. For example, learn how quickly it cooled down after its formation. We also want to figure out if the transformation was a one-time cataclysm or a series of events over billions of years. Nonetheless, we can still dream of the Venus that could have been. A paradise where humans and Venusians could have lived side by side. So keep your eyes on Venus. It's a wild planet with a captivating history. Who knows what other surprises it has in store for us? Let's keep exploring and reaching for the stars.
In our solar system, most planets spin counterclockwise, but not Venus. This rebel planet decided to spin clockwise, and scientists are still trying to figure out why. By the way, why do planets rotate in general? What defines the speed of their rotation? Does the sun rotate? Buckle up and let's try to answer these questions. Venus is the second planet from the sun and the hottest planet in our solar system. Did you know that Venus is sometimes called Earth's twin? That's because it's similar in size and composition to our own planet. But that's where the similarities end, because Venus is a pretty crazy place, to say the least. For example, the weather. On Venus, it's always hot and cloudy. And when I say hot, I mean it like it's over 800 degrees Fahrenheit there. And those clouds, they're not made of water like the ones on Earth. Instead, they're made of sulfuric acid. So yeah, you wouldn't want to go outside without a really good sunscreen on Venus. If you look at the photos taken from its surface, you can see these toxic yellow clouds and cracked, desolate landscapes. And the spacecraft that captured this turned off almost immediately after sending these photos. Poor fella. But the surface of Venus isn't just some solid, dark, flat land. In fact, Venus has mountains that are taller than Mount Everest. These mountains aren't made of rock like the ones on Earth, though. Instead, they're made of a kind of volcanic material that's denser. Venus is a pretty creepy place that holds many mysteries. One of them has been puzzling scientists for years, and this is the planet's rotation. Most planets in our solar system rotate counterclockwise, but Venus isn't like the other girls. It rotates clockwise, and that's not all. It also rotates around the sun faster than it rotates around itself. In other words, a year on this planet passes faster than a day. It's almost like Venus made being quirky its life mission. But why is that? Well, scientists have a few theories. The most popular theory says that Venus was actually spinning counterclockwise like the other planets, but then something happened to flip it around. And what could that something be, you ask? A planet-sized object. Yep, astronomers believe that something huge once collided with Venus, causing it to spin in the opposite direction. You can imagine this like a cosmic billiard shot, with this mysterious huge object being the cue ball and Venus being the target ball. But we can't actually say that Venus is spinning the wrong way. There's no such thing as a wrong direction of spin in the universe. This is actually called the retrograde rotation. This is when a planet rotates in the opposite direction to its orbit around the sun. Venus, for example, has a retrograde rotation, which means that the sun rises in the west and sets in the east on that planet. So now when the horoscope says something like Mercury in retrograde, you'll know what it means. Oh, but Venus isn't the only weird one in our solar system. There are definitely some wacky ways that planets can rotate. For example, most planets in our solar system spin around an imaginary line called an axis. This axis is usually straight up and down in relation to the planet's orbit around the sun. However, some planets like Uranus have a tilted axis, which means it's almost on its side in relation to its orbit. This tilt causes the planet's poles to be nearly in the same place as its orbit. The result? As the planet orbits the sun, different parts of it receive different amounts of sunlight, causing extreme seasonal variations. For example, one pole might experience continuous sunlight, while the other is in complete darkness for a long time. Uranus is the only planet in our solar system that rotates on its side. Scientists think that it could repeat Venus's history. Once upon a time, a large impact knocked Uranus off its original axis of rotation, causing it to tilt at an angle of 98 degrees. We should be grateful for Jupiter. Its crazy gravity pulls all the asteroids and protects us from such collisions. All this is somewhat similar to tidally locked planets. Imagine going on a date with a planet, but instead of being charming and mysterious like you'd hoped, it's just staring at you with the same face all night long. That's basically what it's like to hang out with a tidally locked planet. Tidally locked planets are planets that rotate around their axis at the same rate that they orbit their star. This means that the same side of the planet always faces the star, while the other side is in permanent darkness. Being tidally locked can have some weird effects on the planet's climate and weather. The side facing the star can become extremely hot, while the other side can be incredibly cold. The atmosphere on the planet can also get pretty wild, with strong winds blowing from the hot side to the cold side. And it doesn't have to be planets only. Our moon also works this way. Did you know that we always see only one side of the moon? That's because it's tidally locked to the Earth. We can also take the dwarf planet Pluto as an example. It has a strange rotational relationship with its largest moon, Charon. They're tidally locked, which means that they always face each other with the same side. As a result, Pluto and Charon appear to waltz around a common center of gravity, creating a unique dance in space. But the oddities of our solar system don't end there. There are also planets with super fast rotations. While most planets rotate at a fairly sedate pace, some of them are sonic levels fast. Jupiter, for example, rotates once every 9 hours and 56 minutes, which means that it has a day that's less than 10 hours long. That's fast enough to cause the planet to bulge out at its equator. And also, this rapid rotation creates strong bands of winds that can reach speeds of up to 400 miles per hour. And if all this still seems logical and kinda makes sense, then how about chaotic rotations? Yep. Some planets have a rotation that's so irregular and unpredictable that it's known as chaotic rotation. This is often caused by the gravitational influence of nearby moons or other planets. And it's mostly the case with moons and small objects like that. In our solar system, some moons of Pluto, Saturn, and Neptune have chaotic rotation. By the way, the Sun rotates too, just like the planets. However, its rotation is not uniform. The equator rotates faster than the poles. Pretty weird, isn't it? This phenomenon creates a magnetic field that's responsible for phenomena like sunspots and solar flares. But all this raises an interesting topic. Why do planets rotate in the first place? This may sound like a silly question, but can you answer it? The answer might be trickier than you imagine. It all started around 4.5 billion years ago with the formation of our solar system. When it formed, it started as a large cloud of gas and dust. As the cloud began to contract due to its own gravity, it began to spin faster and faster, like a spinning top. This spinning motion caused the cloud to flatten into a disc-like shape. As the cloud continued to contract, the center became denser and hotter, eventually forming the Sun. Meanwhile, the material in the disk began to clump together and form planets. But because the disk was already spinning, this spinning motion was inherited by the planets as they formed. In other words, the planets rotate by inertia. They inherited the spinning motion of the cloud of gas and dust from which they formed. This is known as the conservation of angular momentum. This is the same principle that causes ice skaters to spin faster when they bring their arms in. And that's a wrap on the wacky world of planet rotations. From the lightning-fast spin of Jupiter to the bizarre backwards rotation of Venus, it's clear that our solar system is full of surprises. But thanks to the laws of physics and the gravitational pull of the Sun, these planets continue to spin on, keeping time with the steady beat of the cosmos. Stay tuned.
Venus has more volcanoes than any other planet in the solar system, more than 1,600. And a day on Venus, measured by how long it takes to rotate once on its axis, takes longer than the time it takes to complete a full orbit of the Sun. Wow! And that's just Monday. An extreme greenhouse effect warms the planet's surface up to 870 degrees Fahrenheit, hot enough to melt lead. Winds there reach the speed of 450 miles per hour in the middle cloud layer, faster than the speediest tornadoes on our planet. The pressure on Venus's surface is 90 times higher than that at sea level on Earth. What a great place for a vacation, huh? And recently, this incredible place has become even more intriguing. In the toxic Venusian atmosphere, there's something that might mean the existence of life. Unfortunately, scientists haven't had a chance to collect any microbe specimens or snap any pictures of life there. But they've discovered a chemical called phosphine, and it's a big deal.
If it's not some previously unknown chemistry that produces the gas, then there must be a kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any normal life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen. For example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. They can also be produced industrially.
The weirdest thing is that phosphine isn't supposed to be in Venus's atmosphere at all. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, the famous gas giants, but on Venus? Totally unexpected. There's no way phosphine can be produced naturally on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere. But it's not nearly enough to explain what the astronomers have observed. It would only make 1/10,000th of the phosphine the telescope saw.
But let's start from the very beginning. In 2017, a group of scientists led by Jane Greaves from Cardiff University started to use the James Clerk Maxwell Radio Telescope in Hawaii. That's a mouthful. The main idea was to search for phosphine gas. It would be a sign of life on Venus. When the data came back and the researchers analyzed it, they were shocked. The phosphine signal was powerful. The team checked the results several times. They wanted to make sure no other substance mimicked the presence of phosphine gas.
So now, does it mean there's life on Venus? Well, not necessarily. If this gas is created by some mysterious organisms, it's a big question how they survive on Venus. On our planet, some microbes can thrive in the environments with the acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid. And even though they have a rather pleasant temperature of 86 degrees Fahrenheit, these clouds contain more than 90% of sulfuric acid. DNA, amino acids, proteins, life components on Earth would be dissolved there in the blink of an eye. The surface of the planet is too hot for any kind of complex molecules to make up life. The Venusian atmosphere is almost 50 times as dry as the driest place on our home planet. There's a theory that microbes might hide in scarce water droplets floating in the atmosphere, but it hasn't been proved yet.
Right now, the research team's waiting for more telescope time. They're going to look for other gases associated with life. But even if they find more evidence, life forms on Venus will be made up of building blocks absolutely different than those on Earth. Or they might be protected by a sulfuric acid-resistant shell. It can be made of such substances as sulfur, wax, graphite, or something else we can't imagine.
Of course, some experts question the idea of life on Venus. They think the gas might be produced during some geologic or atmospheric processes happening on the planet. But the supporters of both theories agree on one thing: the discovery is extraordinary. Interestingly, astronomers have always tried to find signs of life on giant planets' icy moons, or even closer, on Mars. But they've never seriously considered Venus. If additional telescope observations and future space missions confirm that phosphine is produced by living organisms, we can be in for a bunch of exciting surprises. Then people would know of a planet with an alien biosphere, well, alien to us, and this planet would be just next door to Earth. Now, speaking of visiting Venus, though, would it be possible for people to land on this planet? After all, robots are already tooling around the red planet surface. On the pro side, Venus is closer to Earth than Mars, but it also has much harsher conditions. The planet is hotter than Mercury, even though Venus is almost double the distance from the Sun. The temperatures are higher than the melting point of many metals, and some of them, like lead or bismuth, can fall as snow on the highest mountain peaks. If you set foot on the planet, you'll find nothing but barren rock. Giant basaltic plains are littered with volcanoes and mountains. In some places, the surface melts because of the heat underneath. After it releases some of it, the rock solidifies again.
If people ever go to this planet, they will most likely build floating cities in the clouds of Venus's atmosphere. At about 31 miles above the surface, the conditions, like the pressure and gravity, are similar to those on Earth. The temperature is rather manageable too, at around 167 degrees Fahrenheit. Think Death Valley, California on a really hot day. The atmospheric pressure is half of what we have at sea level on our planet. If you went outside, you'd be fine without a pressure suit. The pressure you'd feel would be the same as at the top of Mount Kilimanjaro. Plus, this colony would be protected from the sun's radiation better than one on Mars.
If the atmosphere was the mission's final destination, landing a spacecraft, or rather making it hover in the air, would look very different. The idea is to use an airship in the upper atmosphere for long periods of time. The airship, wrapped in an aeroshell, would enter the planet's atmosphere at a speed of 24,000 feet per second. In the next 7 minutes, its speed would drop to around 1,500 feet per second. After that, a huge parachute would open. It would slow the spacecraft down even more, and then things would get a bit hectic. The aeroshell, not needed anymore, would drop away. The airship would then inflate itself, all the while hurtling through the atmosphere toward the planet's surface. Its speed would be at least 330 feet per second. It would get larger and larger, and its drag and lift would increase. Soon, the parachute wouldn't be needed anymore. The crew would get rid of it, and the airship would fill with air completely. If everything went as planned, it would stop 30 miles above Venus's surface. After that, the airship would travel around the planet. It would be moved by the wind, which can reach a speed of 220 miles per hour at the top of the cloud layer. If you decided to move closer to the surface, though, you'd have to be extremely careful. The wind in the middle layer can get twice faster. The airship could be filled with a breathable mixture of hydrogen and oxygen gases. Such a combination would be less dense than the Venusian atmosphere. It would provide the needed buoyancy, to stay up there. Venus is famous for its super-dense clouds. These clouds make the planet shine bright enough to be seen from Earth. Venus reflects more than 75% of the light that comes from the sun. This reflective cloud layer exists thanks to a haze of sulfuric acid droplets in the atmosphere, and they gather exactly at the height where the airship would float. Luckily, people already have a method to overcome the problem of acidity. A few materials, for example Teflon and some types of plastic, have an amazing acidic resistance. They could protect the outsides of the ship. So, let's say you needed to work on a platform outside. Then you'd be able to do it, wearing only a chemical hazard suit and carrying necessary oxygen supply. Ooh, sounds like fun, huh? Yeah, me neither. In 2020, scientists studied Venus's surface. This planet has a similar atmosphere to Earth. That's why it's so interesting to people. During studies, they discovered there's phosphine in the surrounding gases of this planet. This substance has organic compounds, phosphorus, with carbon or hydrogen combination. This was an important discovery because the colorless, poisonous phosphine may have a biological origin. On Venus, the recent volcanic activity can be a reason for the appearance of this gas. But it's also possible that some bacteria really live there. Now let's move from Venus to Earth, to the Falkland Islands. Beautiful Gentoo penguins live here. Scientists took samples of the penguins' excretion for studying. In the lab, they analyzed the Gentoo's doo-doo and found phosphine there. This discovery shocked everyone. How did the substance that exists 38 million miles away from us got inside penguins? It's hard to believe, but what if these unusual birds came to us from Venus? Maybe they often raise their heads up to see their faraway home in the starry sky. Penguins are rare birds that can turn saltwater into freshwater inside their body. There are unique glands next to their eyes that work as powerful kidneys. It allows penguins to remove salt from the bloodstream. So maybe this same gland can help them survive on Venus in some way. Penguins can't fly only on our planet. But just imagine Venus's atmosphere is perfect for flights. It's possible that millions of penguins are flying on Venus right now. We just can't see them because of the gases covering this planet. Of course, it's unlikely that this theory will find confirmation. Penguins would hardly be able to survive in Venus's atmosphere, which is 96% composed of carbon dioxide. There's also a small amount of sulfuric acid clouds on this planet. But scientists still don't know how the bodies of these birds can produce phosphine. They plan to conduct a thorough study and observe the behavior of Gen 2 penguins. They need to know what the birds eat, what kind of lifestyle they lead, and much more. After the study, scientists hope the penguin phosphine will help identify many different organisms living on other planets. It's possible that inside the penguins, certain anaerobic bacteria produce phosphine to fight other competing microbes. Traces of phosphine can also be found in pond slime on our planet. In the future, scientists are going to send several probes to Venus to explore the planet's atmosphere and find the source of phosphine. There's another animal that may be from another planet. No, not me. This time, it lives in seas and oceans. In 2018, a scientific article was published where a group of researchers stated octopuses were not born on Earth. And this is not a metaphor. They literally called them creatures from outer space. And in fact, there are several reasons to think so. One of the hypotheses says that viruses from other worlds fell into the Earth's ocean and infected squid with shellfish, and forced them to evolve into octopuses. Another theory says the octopus's eggs were brought to our planet on a meteorite. All these versions appeared because of how unique the octopus is. These sea creatures are closely related to snails, mollusks, and squids. But octopuses are much smarter. They are the smartest invertebrates on the planet. Their intellectual abilities are also superior to many mammals, including some guys I went to school with. They have one of the most complex nervous systems of all living organisms. Octopuses have a central brain in their body, and their tentacles are endowed with a neural connection that allows them to think separately from the central mind. Their vision is developed in such a way that their eyes can be compared to the lens of an expensive video camera. They can change color and shape, disguise themselves with a combination of color pigment, nerves, and muscles. But the coolest thing is their intelligence. They can relax and do nothing, be lazy, and have fun. No other creature on the planet has such an unusual appearance and behavior. But the main reason to consider them as aliens from outer space is their history of evolution. In any existing animal, you can track its evolutionary stages of development. For example, elephants and mammoths descended from a common ancestor from the elephant family that went extinct 5 to 6 million years ago. If you look even further, you see almost all mammals descended from animal-like reptiles. Almost every animal has a branch of evolution that has made it what it is. Each species changes over millions of years. But octopuses don't have this branch. They suddenly appeared on the family tree. From the point of view of evolution, squid should evolve into octopuses in millions of years. But scientists can't track the evolution of octopuses with all their intelligence, their tentacles, and their ability to disguise themselves. The octopus genome is unlike any other genome on the planet. If the outer space origin of octopuses turns out to be real, it could confirm the theory opposite to Darwin's evolution. According to this theory, living organisms or their embryos were brought to Earth from outside on meteorites. But for now, there's no evidence to support this theory. Some scientists believe that octopuses separated from the squid line about 135 million years ago. But this theory hasn't been proven either. But if octopuses came to us from outer space, how is it possible that living organisms survived an interstellar voyage? In fact, this is not impossible. There are creatures on Earth that can survive in space, and these are tardigrades or water bears. These are microscopic 8-legged invertebrates close to arthropods. You need a microscope to see them, but even a cheap one will let you see them in detail. From the outside, they look somewhat like bears. They are called water bears because they require a thin layer of water around the body to prevent dehydration. These creatures have been found in all kinds of environments, from the depths of the ocean to hot sand dunes. They are incredibly tenacious thanks to their unique structure. They look soft, but their body is covered with a hard cuticle. This covering resembles the exoskeleton of grasshoppers, mantises, and many other insects. Water bears shed the old cuticle layer to grow. Each of their 8 legs has 4 to 6 claws, which helps them cling to any surface. The tardigrades manage to survive at a temperature of minus 328 degrees Fahrenheit. This is almost 3 times colder than in icy Antarctica. Hot conditions aren't a problem for them either. They have survived a temperature of 300 degrees Fahrenheit. This means they exist in boiling water. Water bears aren't afraid of radiation or high pressure. In the depths of the ocean, pressure can destroy alloys of strong metals. The water bear can withstand pressure 6 times heavier. But the coolest thing is that they can live in the vacuum of space. Our planet has a magnetic field, that is, a shield that protects us from solar radiation. Tardigrades don't care about this radiation. They can go into low Earth orbit and return unharmed. Their body strength is provided by a protein that protects their DNA from ionizing radiation. Tardigrades can also fall into a state of cryptobiosis. If the surrounding conditions suggest freezing, drying out, lack of oxygen, or an overabundance of salt, the tardigrade pulls its head and legs inside the body and falls asleep. It can stay in the form of an unmoving barrel until the conditions around it improve. This state of cryptobiosis allows them to live without water and food for decades. In 2016, scientists managed to revive 2 tardigrades that had been sleeping for more than 30 years. These creatures have survived 5 global catastrophes on Earth. They appeared about 5 billion years ago, and it's possible they'll live just as long. They aren't afraid of any apocalypses. Asteroids hit our planet, a supernova explodes nearby, and its radiation splashes out on Earth. A global heat or ice storm starts. People and most living creatures may not survive these events, but the water bears can.